think about GPS is a good example. GPS is kind of a miracle technology, I think. And it covers the whole globe and gives you XYZ positioning anywhere on the face of the earth. But the uncertainty circle, that big blue circle you see on your phone when you pull out a map, can be 3, 6, 9 meters. And that's sort of good enough to get you down the highway or to get an airplane to a new city. But almost all human work and almost all robotic work happens within a much smaller circle than 9 meters. Your average room, your average factory cell. Plus GPS doesn't work indoors really. And so what we're doing is bringing that same idea of navigation but at the millimeter scale, indoors or outdoors, and totally independent of lighting conditions. But again, GPS is a good example because it originally designed for military positioning and various weapons applications, and then ends up just opening this huge explosive world of novel applications that nobody really thought of when it was first created. We think of our microlocation system as a similar kind of platform technology where we're addressing some use cases now, very real problems in industry that we can solve, but there's also a whole world in our future of lots of different applications that some of which we've thought of and patented, others the users are going to think of and the market is going to think of. I don't think our system will probably ever be used solely in isolation. All robotic systems today uses mixes of sensors. They have their strengths and their weaknesses. But right now there's no solution for millimeter scale precise positioning in the kind of harsh environment of a manufacturing world where there's strange lighting conditions and lots of different types of stuff around. And many of our customers have tried lots of different alternatives, and they come to us because we have the solution to that problem. The Humatics microlocation system can pinpoint a transponder, or actually many transponders, to a millimeter scale, often as low as 1 millimeter or smaller, position in space. We don't do any blobology, which is we don't look at a big dot cloud of echoes and try to apply all kinds of algorithms to get 80% certainty on what we're seeing. We see something and we pinpoint, we know exactly what that thing is, it has a unique digital tag, and we know exactly where it is. And so it eliminates the blobology, which is difficult to bring up to a very high standard of reliability and certainty, and gives you very precise positioning, which requires that you know very precise positioning of what. If I tell you my hand is here to a millimeter, it's hard to say what do you really mean by my hand. What we do is we say there's a particular point on your hand, we know exactly where that point is. Our system basically will navigate the relationships between people, places, and things. Sometimes I think about that as people, robots, and machines in an industrial setting. So there might be a sort of small wristband that's on a person. We're building the transponders in a safety equipment that people already are wearing. You might put it on top of on a robot, or also on a workpiece or a mobile cart. And we engineer very high precision relationships between these things. And that is enormously valuable because it provides, it just improves the flexibility of all different kinds of production systems. Makes them more efficient to change, makes them less prone to downtime for various reasons. And the whole Industry 4.0 push is really about reducing the fixed capital, 10-year footprint of robotics and other systems, making them more flexible, more collaborative, less walled off from the human work. Fundamentally, Humatics is focused on bringing robots and other autonomous systems to work in human environments.